Now, if you remember from last time, we had Hello World Rev 0, 1, and 2, and you'll find that those are in your directory, and this is our workspace here, MCUXpresso. We can see these three files here. I'm going to right mouse click, and I'm going to go down here and say Open Project so that I can actually clone it. And if you remember how that works, we just right mouse click and say Copy, right mouse click here and say Paste, and we have a new revision as long as we just say Copy here. Now, if I close this one, close Project here, and if we take a look at our memory stick, we can see that we already have Rev 3 in here. Now, what would happen if I did right mouse click and I said delete? I've got two options here. And the two options are just delete it and say OK. And if we do that, we can see that it still exists here, but it's no longer in our workspace. Now, if we want to bring it back, we can go up here and say File, Import. And then it's going to come up here and we're going to go to existing projects into Workspace. We're going to say Next. And we'll see here that it's going to come up with the Hello World Rev 3. So we're just going to do that and say Finish. And it comes back in. However, if we right mouse click here and say Delete, and I click on Delete Project on Disk, when I say OK with this checked, it disappears and it's no longer here. So you have to be careful. Every time you create a project or work with it, it'll save the revision here. And we can go up here and say go like this. And I can say right mouse click and say delete from the workspace. And as long as I don't click here, all those files will still be here. And what we're going to do is import another SDK example. So we're going to click here, make sure we choose Freedom K64F. We're going to say next. We're going to go here to Demo Apps again. Under Demo Apps this time, we're going to go to LED Blinky, and we're going to say Finish. Once it comes up here again, we're going to change the name. We're going to rename it to LED Blinky Rev 0. Now, if we open this up and take a look at our source code here, which we have on our screen, we're going to be using something called GPIO. And GPIO stands for General Purpose Input Output, how General Purpose Input deals with our LED. So the first thing we're going to do is we're going to take a break here and take a look at Daplink. If you double click on the Daplink icon here, it's going to show you the contents. There's details.txt, which is very small, but you also have an embed.html, which is a web page. So if you right mouse click and say open with, I don't know, let's put in Firefox here. It's going to bring up all the details about the Freedom K64. Everything from overview, MCU features, board features, and so on. But the most important thing for us is the technical doc. And under technical doc, we can find the reference manual, which has got a lot of information about the Freedom K64. In fact, if you look all the way down to the bottom here, it's got over 1,700 pages, but the most important part for us is the part on general purpose input-output. Altogether, there are 1,789 pages in this PDF manual. At any point, because it is a PDF, you can save it off to your memory stick and have access to it anytime you want, and you don't have to be in the lab looking at Daplink. Now, GPIO on our board here is made up of 5 ports, port A, B, C, D, and E. And each of these ports has 0 to 31 or 32 pins per port. 32 times 5, that's a pretty big number, and it actually ends up being more than the number of pins that are coming out on your Freedom K64 chip. So not all of these port pins will be available for us to connect to. Of these 5 ports for the general purpose I/O, port B has the red and the blue lead attached to 2 of the pins on port B, and port E has green lead connected to one of the pins on port E. Let's take a look at MCUXpresso and see how we can find this information out. Here we are back in MCUXpresso with this same code that we looked at earlier. What I'm going to do is bring up a couple new windows. I'm going to go down here to Show View, and I'm going to go down here to Peripherals. Now it's going to throw it somewhere, but it could put it anywhere. We could put it there, we could put it here, we can move it anywhere we like. I happen to like it over here, and I can actually just say, let's put Peripherals right in the same slot as this, and it all shows up here, which is kind of cool. Now, of all of the things that are in our peripherals here, the only thing that we really care about is GPIOB, which is this guy, which has got our red and our blue LED on it, and GPIOE, which has our green LED. And you'll see here that these have certain addresses associated with them. And so what we want to do is take a look at a way to look at what's in these addresses and change what's in those addresses. And we can go back to Window here. We can say Show View, and we can say Other. And under Other, we can go to Debug and open up the memory browser, and I can just say Open, and I can put it here or just put it anywhere I want. And some of the addresses that we need to know about with GPIOB here, as it says, is 0x400F F040. So let's put that value in here, 0x400F, F040. And these addresses here are going to affect what's going to go on our red LED. And you can see here, as it says, there are 6 registers, 1, 2, 3, 4, 5, 6 registers for each of the 5 GPIO ports, which is A, B, C, D, and E. The one that we're talking about is pin 22 is where our red LED is physically connected. 4-digit hex value that will affect the red LED is going to be 004 and a bunch of zeros. And if we take a look at here, that's all zeros here, that's 00, and then 0100, so that's 4, and then 00000. And so putting this number into one of these registers is going to have effect on our red LED. Now in our main program here, the first line that's always executed is board InitBootPins. And watch what happens when I step into this. Notice we've got some changes up here highlighted in red. This address, F040, which is this one, the port data output register is set so that this is going to be an output pin here, which is what we need to drive the red LED. And over in the far right here, we have 004 again, and that's that address. And you can just click at the start of this, and it'll tell you that that's 54. And address 54 is a port data direction register, where again, we want that port to be output. Now we have some other registers in here that we're going to look at, and we'll be able to actually change the value that's on our red LED and have it turn on and off just by toggling values in these addresses. One of the things you got to remember though is that a 0 is going to turn on our LED and a 1 is going to turn off our LED. Now, one of the things you're going to notice here is that if we want to use the port set output register, that's going to turn off our red LED. Now, we haven't done anything yet as far as changing values here, but we're going to do the port clear because any value that we put into 48 is going to turn on that red LED. So that's 40, let's see, 44, 48. So let's put in a value of 00 or 00. And you can see that the red LED has come on. So that's our port clear register because any place where you have a 1 is going to turn on the clear function here, which is going to make that pin go 0, which is going to turn it on. Now, that's the port clear output register. Use the port set output register, which is what we see here is address 44. Let's click here. We can see the 44, so we put up 0040 and the light goes off. So these are 2 registers that we can directly affect, but there's one other one that's really cool, and that's the toggle output register, which happens to be address 4C. So let's take a look at address 4C. There we go, 0040, light goes on. Let's go back to the start of that thing again, 0040, and the light goes off. And that's what a toggle register does. Every time you put a 1 in that position where the red LED is, it's going to change the state from on to off and off to on as you keep changing that. That's basically what our code is going to do. Now let's see what's going to happen when we actually run our code. I'm just going to hit the run button, and you'll notice that the red LED is blinking. And this is a part of the code here that's doing it. GPIO port toggle. And what it's going to do is take the 1 here, a value of 1, and it's going to shift it to the left. How many times? It's going to shift it 22 times because that's where port B pin 22 is, and that's the one connected to the red LED. So all it's really doing is putting 1 here, and the next time it's toggling it to make it a 1 again. Every time it puts a 1 into that pin 22, it's going to change it from being on to off to on, and it's using this system tick here to make sure that we're going to be using 1,000 units, or basically 1 second between each one of these coming up. And that's how this code works at this level, but it's working below here by toggling various values in here. Let's take a look and see how we can sort of start playing without doing any coding at all with the blue LED on port B and later the green LED on port E. Now, if we want to look under the hood, one of the things we can do is go over here to LED Blinky Rev 0 Max. And if we double click on this, if we get pins, we have this diagram coming up of our entire CPU. What I'm going to do is I'm going to click on PT pin 21, which is our blue LED. I'm going to go to GPIOB, and notice it's already popped it up here. I'm just going to say done. If we look at our original one here, GPIO pin 22, port B pin 22, it knows it's a red LED. And just by selecting this, it knows right away that this is a blue LED. Now, we haven't specified yet whether it's input or output, so I'm just click on this. I'm going to choose output, and I'm going to also make it a logical 1 to begin with, which means it's going to be shut off to start because a 1 turns it off and a 0 turns it on. Now, if we want this to actually go into our code, we have to click on up here, update code, and say OK. And once it does, it's built it. But what we have to do, even though we've updated our code, to do is stop here. And for it to take effect, we have to then hit the debug and have it build and put all this stuff back in. And when it does, then we're able to then manipulate the blue LED. Let's go to our peripherals. Let's go down here again to GPIOB. And there's our pins here that we're going to see change. And let's put up again here, just hit enter, and here's our numbers. Now, just to start off with our code here, instead of just seeing the 4 coming up here, we're now seeing a 6 and a 6. Why are we seeing a 6? Because if you remember the diagram, you're going to see that pin 22 and pin 21 are right next to each other. And instead of being a 4, it's a 4 plus 2, which is going to give us our 6. Okay, so one of the things we're going to look at here is that we've got our port set output register here. And if we do that, something's going to go off, but if we do the clear register, which is on 48, it should come on. So 48, if we look at it over here, I think this is 4C, so that's 48 there. So right now I'm going to go 0020, which is our blue LED. And if I go back here and also say 0040, it's going to be purple, which is a mix of red and blue. If we go over here, we can toggle one of those off. We can say, okay, let's click here on our toggle register 0040, out goes 1, 0020, 0020, out goes the blue. So we can do whatever we want with these, but if we run our code, you're going to find that all it's going to do, because there's no coding with anything other than red, just with the red itself and nothing with the blue, but we can manipulate it over here. To make any changes to party, again, we have to go up here to pins, and we have to know that it's pin E26, which is this guy. And we're going to say basically here, GPIO and 26 and done. And again, what we find here is that it knows that it's the green LED. We have to specify that it's definitely output. And we also want to have a logic 1 to start. And at this point, we can just go up here again to where it says update code and say OK. And once it's finished doing the update, again, what we have to do is basically stop what we're doing here. We're going to have to go up in here and basically debug again and put it on the board. And once we do, we should have everything we need to do to actually start toggling the green LED as well. So we're about ready to go. Let's again put in this address here. And let's take a look and see how things are going to initialize a little differently before we start. Notice down here, we've got some numbers here because this is where our green LED is here. I've got everything set up at this point to deal things with the green LED. And we want to, first of all, turn it on. So that's going to be the port clear register, which is at 108. So if we go down here to 108, which I believe is this guy, we put in 0400, green LED is on. And if we back up one here to the port set register, which is 104, we can put in 0400 and it goes out. And we also have the toggle register as well.